had a question about section 3.8, number 10. This question asks me to find the second derivative of a function that is defined implicitly. And so we're going to find the first derivative and simplify, then find the second derivative and simplify. The and simplify part is where we're going to run into some problems here. So let's take a look at this one. I already have it worked out, but I want to talk you through it because it took quite a few steps to get this all the way simplified. Alright, so first of all, we're taking the derivative of the original function, thinking about the square root in power function notation as y to the 1/2. So its derivative will be 1/2 times y to the negative 1/2 power times dy dx plus, and then we're going to use the product rule. Oops, I got the wrong tool selected. I'm going to use the product rule, there we go. The product rule on that 3xy piece. So the derivative of x is 1, so 3x times 1 plus, leave the 3x alone, times the derivative of y, which is dy dx, equals the derivative of 2 is 0. Okay, moving from there, we're trying to get dy dx solved for. So there are two dy dx terms. So we are going to subtract the 3y to the other side, and then factor dy dx out of these two terms. So we'll have the 1/2 y to the negative 1/2 plus 3x times dy dx, and then I can divide that over to the other side. Okay, now, again, I'm going to need everything simplified if I'm going to have a chance of getting my second derivative, so I'm not allowed to have a negative power in the denominator. So first of all, I write it in the denominator of its little fraction, so I put it in the bottom with that 2 as a positive 1/2 power, and then I'm going to multiply top and bottom of my common denominator, which is that 2y to the 1/2 power. That gives me 6, negative 6, y to the first times y to the 1/2 is y to the 3/2 power in the numerator, and then those will cancel off here, give me just the 1, and then 6x y to the 1/2 power. That's our first derivative fully simplified. Alright, next we're going to go ahead and take the derivative of that derivative, moving into the second derivative here. Now, when I take the derivative, this is going to require the quotient rule. So we're going to start with the bottom times the derivative of the top. So the derivative of the top will be negative 6 times our power, that little dot right here, that's just multiplication. It's not a negative, it's kind of small and hard to see. It's just a multiplication by the 3/2 power, then subtract 1 from the power, y to the 1/2 power, and don't forget we're chain ruling, times the derivative of y, so dy dx. Minus, leave the numerator alone, take the derivative of the bottom. The derivative of the 1 is 0, then I'm going to have to use the product rule on the 6xy to the 1/2. First, the derivative of x is 1, so I just have 6y to the 1/2, then plus. We're going to leave the 6x alone, times the derivative of the y to the 1/2 piece, 1/2, y to the 1/2 minus 1 is negative 1/2 power, chain rule again, times the derivative of y. Okay. So I took in the next line and distributed just the 6 times 3/2, that's 9, y to the 1/2 through, so it's 9y to the 1/2, and then times 6 is 54, x, y to the 1/2 times y to the 1/2 is y to the 1. I let the dy dx factored out. Okay, my two negatives here became positive. I distributed a positive 6 through both of these parts, giving us 36. And then y to the 3/2 times y to the 1/2 is 4/2 or y squared. 6 times 6/2 of that is 18. There's an x, and a y to the 3/2 times y to the negative 1/2 is a y to the 2/2 or y to the first, dy dx. Alright, now don't forget that we know what dy dx is equal to, so we have to sub in dy dx for dy dx. We're subbing in the first derivative. This is where the simplification really starts kicking off. So now I am going to multiply or distribute the negative 6y to the 3/2 through the numerator over here, so that I can get this, leave the denominator alone, so I can get this thing simplified. So that 6 times 9 is 54, y to the 1/2 and y to the 3/2 is 4/2 or 2 is the power of y. 6 times 54 is 324, x, y to the 5/2 now when we add up 1 and 3/2. Okay, the 36y stays by itself. The 18 and the negative 6 make a negative in the front there, 108. You've got x and then y to the 5/2 again. Okay, all over your common denominator. So, since we have that lovely common denominator there, we're going to multiply top and bottom by that common denominator because we need to clean this fraction up. We can't have fractions over fractions or it's not considered simplified. When I distribute that through, it's going to multiply and reduce with the denominators in those two fractions. You can see that the numerators just came back out. But in the 36y squared case, we're going to have to distribute that through our 1 plus 6xy to the 1/2. And the denominator, I already had 2 of that same thing, so 1 more gives me 3 for the new power there in the denominator. Okay, looking down a little further, we kept those terms the same. We distributed the 36y squared, and the 36 times 6 is 216. X, y to the 2 plus 1/2 is 5/2. Now notice that we have a lot of like terms. We've got 54y squared and 36y squared adding up to 90y squared. And we also have the 324 xy to the 4th, the xy to the 5/2, the 216 xy to the 5/2, and the minus 108 xy to the 5/2. They're all like terms that add up to 432 of those xy to the 5/2. Okay, and just a few more things to clean up. Remember that the original question, where is it? Oh, I have to scroll back down. There it is. The original question was written in radical function, I meant to say, notation. So it's got the radical in there. So we're going to go back and get rid of our fractional powers, writing this one in radical function notation. Oh, sorry, my window keeps trying to maximize. There we go. So we are going to replace our half powers with square roots, and then that 5/2 power, since there are more than 2, we can divide that out and write that as y to the 4th times y, and the square root of y to the 4th is y squared times the square root of y that's left over. Then there is a common GCF of 18y squared that we can factor out, and that leaves us with 5y. Ooh, oops, got a little typo right there. I'm going to fix that. I took the y squareds out. I should just have a y right there, right? There we go. I'll fix that. And again, I was retyping this, so I copy and paste a lot when I retype these. So 18y squared came out. That divided into just 5 right here. Then I have the 432 divided by 18 is 24. The x is still there. The y squared was factored out, and the square root of y stayed. Our denominator stays the same. Nothing's able to reduce, but we have this thing lovely factored form reduced.